Okay, last sessions on the Friday, so the speaker also has introduced the concept of deep foundations on skin friction and also bearing capacity, filing equipment and its installations. So by meaning, for deep foundation, there are two categories of the pile which can be classified according to the installation method. What I mean here is, for example, kalau kata the pile is driven or displaced pile, like for example, we are using the jet pile, ataupun the pile is constructed by having a hole and then you place in concrete inside that. So that is we call as a bore pile. So by definitions, if you have a textbook, so you can turn to the page 493 by Whitlow, Basic Soil Mechanics. It says that from the design and construction, the piles are classified into two types. For the first one, driven or displaced pile or displacement piles, which are usually performed before being driven, jacked, screw or hammer into ground. So itu yang dia katakan sebagai driven pile. And then for the second type of the piles is called bore or replacement piles, which require a hole to be first bored into, which the pile is then formed, usually of reinforced concrete. So the speaker also introduced there are few types available on the pile type according to the material, and also having a different shape of the pile. For example, we're going to have a square pile, and then we're going to have a hollow pile, circular pile, and then you heard on the micro pile, span pile, concrete pile, steel pile. So the piles are depending on the function and also the load carrying capacity. So kalau kata you have so many piles from different materials, you go to the manufacturing factory and then you are required to choose which is the pile that's suitable to your project ataupun to your construction project. So you have to decide whether you are using the driven pile or the bore pile. So the speaker also tells you the advantages and disadvantages using this pile or this kind of different material of piles. So I hope that you are familiar. So when talking about the piles, so in terms of design and construction, we can classify into two. However, the pile also can be classified according how the load carrying capacity to the ground. For example, the pile on the functions as an end bearing and also the pile as function on the skin frictions. So let me share a slide that focusing on our talk this morning, our lecture. So by definitions or by the concept, looking back to this one, assuming that you have a slender structure which called as a pile. So bila kita kata slender structure ni, pile ni, the basic requirement is that the pile can go more than 3 meter depth. Itu yang first yang you kena familiar lah. Kemudian in terms of the design requirement, itu yang kita look at back to the shear failure, kemudian dia punya limiting settlement, and then ada 3 benda lah. Tapi the thing is that when talking about differences between shallow and deep foundations, we can say that for the shallow foundations, the embedment depth is limited to the 3 meter only. However, if you have some kinds of very problematic soil, and then you need to go deeper than 3 meter at particular time, during this time, the shallow foundation is not more applicable for your construction project. Thus, you need to choose or you need to decide on having a deep foundation as a as a deep foundations ataupun pile lah. Piling ni kita pergi bila kita dah dapat keputusan yang mana daripada soil profile you have a very kind of soft soil, kemudian with a very high load carrying capacity, so you need to go to the piling. So dalam piling ni dia ada banyak jenis lah, bergantung kepada jenis material dia ataupun jenis function dia atau lebih mudah jenis installations or construction method. Okay, by its function on the load carrying capacity, we can see that the ultimate bearing capacity of the single pile, for example, it can consist of the QP ataupun end bearing capacity, which is equal to the QP AP, and also consists of QS, the skin friction capacity. The skin friction capacity QS is equal to the FAS. So what is the F? F is the unit friction resistance. AS is the area of the shaft. QP is your unit bearing capacity. AP is the area of point. So you may see later on the elaborations what is the F is actually and what is the QP is actually. It's depending on the pulse in sand ataupun pulse in clay. So you akan nampak lah the variations of formula will be changed accordingly to the locations of the soil type. Kalau kata you need to construct pile in sand, so the formula will be changed according to the soil sand properties. Kalau kata you have to construct a single pile in clay, that will be also different for the QP as well as the QS. So what is the D? D is the embedment length. So ada pile yang kita akan nampak dia fully embedded. Maknanya kata macam last talk, the speaker said that for the first installations of pile into the ground, so kita akan letakkan shoe pile. Kemudian bila you dah letak shoe pile, you penetrate into for the maximum, for example 6 meter length, and then there is more another required of the pile to be extended, so kita akan pakai extension pile. So the setiap length of the pile will be differ according to the manufacturing product lah. Ada 6, ada 9, ada 12 bergantung kepada availability. So D is referring to the embedment length. Ada pile yang memang fully embedded dalam tanah into the ground. Ada pile yang datang daripada manufacturing is a 9 meter for example, but then embedded only in 8 meter. So 1 meter is on the ground surface. So you have to careful lah bila you calculate ataupun you have the problem to analyze the bearing capacity of the single pile. And then the AP is the area of the point is depending to the cross-sectional area of the bottom pile. So if the cross-sectional area of the bottom pile comprises ataupun the pile is in a circular form, so kita akan pakai area of the pile at the bottom as a pi d squared over 4. But somehow the pile is not in the circular shape. It can be a square shape. So in order to have the cross-sectional area of the square shape, is the simplest as the P darab dengan L. So that's how it says that AP ni is not always as a pi d square over 4 ataupun cross-sectional area of the circular. So dia bergantung kepada bentuk pile awak. Lepas ni you akan tengok lah ada setengah coefficient parameter in calculate the analysis bergantung juga kepada jenis material of the pile. So have to be careful when you are looking to the data from table to analyze in your ultimate bearing capacity. Okay, this is assumptions on the load bearing carrying capacity from different researchers. So this is what I said. What we're going to have pi according to the its functions. Kalau end bearing pulse, maknanya dia akan tanggung beban pada bottom. The strength or the functions at the bottom of the pile. Tapi ada setengah pi tu dia punya functions pada frictions pi, yang mana dia adalah resistance between pi and the soil interactions. So this is I'm not going to further explain because the last Friday speaker had explained to you. Okay, some piles can be combined according to the loads. Ada loads yang dalam bentuk moment, and then the combination between vertical loading as well as the horizontal loading. For example, in the offshore area. So that kita panggil sebagai raking piles. So bila combinations pile yang mana dia ada end bearing, kat situ juga dia ada skin frictions, maknanya the pile will carry higher load capacity and more stable compared to other pile. So this is what it says that bila kita ada some kinds of the bore pile that will be required for the certain applications and construction sites, yang mana you're going to construct or you're going to excavate first a hole before you forming and cast in situ concrete supaya dia boleh dapat menghasilkan sebentuk pile. But other problem in the bore pile such as segregations. Yang mana you akan nampak lah bila pouring process concrete into the hole akan ada berlaku some honeycomb in the concrete formations. So try to avoid that formations by having a slump test in the early stage before you pouring the concrete into the ground. Okay, the ultimate bearing capacity of the single pile can be calculated through the static approach. So the assumption consists of the QU is the ultimate bearing capacity of the pile equal to the end bearing capacity QB plus dengan skin capacity ataupun ultimate shaft resistance QS. So basically we're going to have W, but somehow the W can be ignored. And the W is equal to the weight of pile minus dengan weight of soil displaced. So dalam this analysis untuk static approach, so kita akan andaikan W sama dengan kosong. Logically, when you penetrate a pile into the ground, there's some resistance between the pile itself and also the soil structure. So it's create the frictions. So the frictions force will be acting upward. So ini yang keadaan yang mana bila you penetrate downward akan ada satu daya ataupun shaft resistance yang melawan arah penetration in upward directions. So this is supposedly in the natural. Later on you may see that how this will be different by having a negative skin frictions. So according to this figure, the QU consists of the QS plus dengan QB. QB is the end bearing capacity at the bottom of the pile where it is rest on. Sama ada dia rest on hard stratum ataupun dia hanging. So it depends. So yang ni pun I have explained that. So the area of the shaft AS is depending to the perimeter of the pile itself lah. Contoh kalau kata kalau kita ada circular pile, the bottom area of the tip can be calculated as the pi b square ataupun pi d square over 4. However, for the skin shaft area is calculated as the pi times dengan PL. So kalau you ada square pile, so kita punya AP dia adalah P darab dengan L. That is the area at P. Tapi kalau you nak calculate AS, so you akan dapat formula dia sebagai 4. Kita ada sides. We have 4 sides times dengan area dia adalah B times dengan L. So berbezalah untuk circular dan juga square pile. Okay, normally bila kita dah calculate ultimate bearing capacity, so kita nak tahulah dia punya allowable bearing capacity, and then we want to estimate the design load. So it also can be found as previous in shallow foundations. So kita boleh calculate the allowable bearing capacity QA as equal to total summation QB plus QS over dengan factor of safety. So kalau kata you want to calculate separately, so you can have as this example ataupun from the first equation as QB over FB plus dengan QS over FS. Okay, now we go further details how to analyze piles in cohesive soil. So there are 3 methods available according to the conditions of the soil itself. So for example, contoh kalau kata kita nak analyze pile in clays, clay ni adalah bentuk yang mana dia punya keupayaan air ataupun permeability of the soil is very low. And during that times, once you apply loading, they can have a changes. It's a very fast actions. So somehow the evaluations on pore pressure cannot be assessed due to the fast actions. So the condition can be split into few types. Maknanya kata when we want to calculate or we want to analyze the strength of the clay, whether it is in the short analysis, short-term analysis ataupun long-term analysis for total stress ataupun effective stress analysis, you might have some familiar in terms of the strength parameters itself. So kalau kata talking about the total stress analysis ni, selalunya dia tak melibatkan dengan pore pressure measurement lah. Maknanya dalam conditions ni it's in undrained conditions. So bila you tested on triaxial test, it's kind of we having a CU consolidated undrained ataupun UU, yang mana you are not allow for any drainage to occur. But then the pore pressure, the excess pore pressure cannot be assessed. So this is the term when you have the strength parameters in the total stress analysis. Ataupun you want to estimate the stability of the clay in the short-term analysis. So what we're going to have is that bila you ada this kind of problem, you want to construct a pile in clay dengan conditions as a short-term analysis, we're going to use as a alpha method. So the alpha method introduced to you by having the F is a unit addition of the skin frictions dengan persamaan dia adalah F sama dengan alpha darab C. Alpha is a factor that relates addition to coefficients and C is a coefficient of clay. So by looking to this formula, you akan nampak yang mana the QB, ultimate bearing capacity at bottom ataupun at base of the part, is equal to CUNC plus dengan CUNC times area of the base plus dengan summation alpha average CU times dengan delta AS. So the NC is a Scampton ataupun Terzaghi bearing capacity factor, where it is introduced 9 for intact clays or 6.75 for fissured clays. So the alpha is an addition factor usually taken as 0.45, but may vary from 1 for soft clay to 0.34 over consolidated clay. So the CU is the undrained strength at the pile tip. Maknanya kalau kata you have a single layer of pile and then pile at the bottom pile rested on the CU equal to 80 kPa, so kita akan guna 80 kPa untuk masuk dalam first term CU di dalam persamaan ni. Kemudian delta AS is the shaft surface area within a given layer of UD strength CU, and the average CU is the average undrained strength along the pile shaft. So yang tu yang kita akan perhatikan lah, yang mana bila you nak calculate untuk QS ni, kita akan ambil average CU, average undrained coefficient. Okay, the next method untuk calculate pile in clay ataupun pile in cohesive soil, when you are considering for the long-term effect ataupun effective stress analysis. So at this particular time, it is introduced as a beta method. So the beta method will be having a different formula from the alpha, yang mana kalau you tengok dekat QB ni, dia masih lagi sama, iaitu CUNCAB, tetapi dia berbeza pada QS, iaitu K0 times dengan average overburden pressure ataupun average effective overburden pressure at the center of the pile length times dengan tangent delta times dengan AS. So the beta S is actually comprises K tangent delta. So beta ni adalah K tangent delta. So itu adalah beta. So beta is similar to the alpha, iaitu addition factor. AS is the shaft surface area, average effective overburden pressure at the center of the pile length, sigma naught, and the K naught. K naught is the earth pressure coefficient at rest. So kalau kata you have seen the symbol in the previous course in the soil mechanic, so you dah tahu dah macam mana yang kita define K naught, atau in any application, for example returning wall. So you may see that how the wall ataupun soil in active zone, passive zone ataupun at the rest conditions. Okay, the next method is by having a lambda method. Yang mana lambda method ni pun dia akan affected in the term for QS. So it seems to the beta dan juga alpha. So lambda is considered as an addition factor. And then AS is the shaft surface area, average effective overburden pressure at the center of the pile length. So yang tu yang memang kita akan ambil lah untuk calculations. And the CU is a mean undrained shear strength. And this kind condition we consider the phi sama dengan 0. Okay, yang ni yang lebih kepada dia punya explanation lah. Yang slide tadi tu lebih kepada summary formula apa yang kita ada untuk kita calculate ultimate bearing capacity pulse in clay. Okay, it is common to assume undrained condition exists at the time of loading, but recent studies have shown that distributions of excess power pressure take place fairly quickly. This is what I said. Bila you ada satu loading, you apply on the clay, clay can behave in the total stress dan juga effective stress bergantung kepada allowing the excess power water pressure. And when you look at back to the properties of the clay having a low permeability. Maknanya nilai K dia adalah rendah. Yang mana air untuk mengalir keluar is very long period of time. That's why by somehow clay ni can be analysed in total stress. Dia juga boleh analyse in effective stress. Dan juga dia boleh analyse dalam different as a purely cohesive clay. Okay, yang alpha method ni pun sama yang macam tadi tu. Yang ni lebih besar sikit lah. Okay, yang ni dia nak tunjuk macam mana kalau kata kita nak dapatkan nilai alpha by having a relationship where you are given the average undrained shear strength. So contohnya kalau you ada 200 kPa is your average shear strength, average CU, and then the alpha can be found from here. Maknanya dalam this value lah for the alpha 0.26 for example. Ada juga recommendations given the idea how to obtain the alpha according to this one. Contohnya kalau undrained condition less than or equal to 25, so kita boleh ambil alpha sama dengan 1 ataupun in the range 25 to 75 kPa atau alpha sama dengan 0.5 kalau CU lebih daripada 75 kPa. Okay, yang ni untuk beta for long term ataupun effective stress analysis. Okay, berbeza dengan total stress analysis dengan effective stress analysis. By this time, untuk effective stress analysis, the excess power water pressure that develops when piles are driven in saturated clays gradually dissipated. So yang ni kita akan nampak lah pada tempoh yang panjang, the excess power water pressure develop. Then dia dissipate from the conditions of the clay itself. So the unit frictional resistance for the pile can be determined on the basis of the effective stress parameters of the clay in the remolded state. So yang ini perbandingan kalau kata you want to analyze for the long term stability of the pile, so kita akan menggunakan kaedah beta. We're not going to use the alpha ataupun lambda methods. So yang ini pun sama. Okay, back to this formula untuk beta. The K naught is the coefficient at rest can be calculated or estimated from these equations 8.39 iaitu 1 minus sin effective P ataupun K naught sama dengan 1 minus sin effective R square root times dengan square root OCR. So if you study on the clay itself, sebenarnya clay ni dia ada conditions yang mana clay dalam normal consolidated, clay dalam keadaan over consolidated clay ataupun clay dalam keadaan under consolidated. Mana bila kita buat perbandingan, kita nak tengok the present stress pressure adakah lebih tinggi daripada sebelumnya, tempoh yang sebelumnya, iaitu kita panggil sebagai pre-consolidation pressure. So the measurement can be counted sama ada to determine whether the clay in OCR ataupun NC by having a ratio. Kalau kata OCR you lebih daripada ratio you lebih daripada 1, so kita classify sebagai over consolidated ratio. Kalau kata you calculate and then the ratio is equal to 1, so kita boleh kata the clay is a NC. Maknanya the present overburden pressure is similar to the pressure that the soil has experienced before. Nilai tegasan sebelum dengan semasa lebih kurang sama, so the clay in normal consolidated. So when you look at to all the research interests, the clay much more very complex compared to the sand. Sebab bila kita tengok balik dia punya karakteristik compared to granular soil, in terms of the index properties, the grain size distribution, you akan nampak the clay is very finest. Walaupun dia ada silt, dia ada the clay itself dengan clay mineralnya, dengan dia punya low permeability, that's why the study more interest in the clay. So you akan nampak lah macam mana clay ni behave in different way bila kenakan loading untuk long term ataupun dalam short term stability. Okay, yang ni pun yang sama, cuma berbeza kepada lambda. And the next slide, you may see that the detailed explanations how to get the average effective overburden pressure at the center of the pile length dan juga average mean shear strength. So this is how you can see that the calculation to determine mean CU dan juga mean effective stress. Look at this example, assuming that you have embedded depth of the pile ataupun you ada total length L and different depth L1, L2, L3 having a different undrained coefficient CU 1, CU 2, CU 3. Maknanya setiap layers clay soil ni dia bagi nilai CU berbeza. So you may see that how the undrained coefficient may increase linearly with depth, so that when you want to estimate the mean CU in the lambda method, this is how supposedly being given or being calculated. Okay, just now pile in clay. Right now we want to concentrate or we want to analyze pile in cohesionless soil. So when it says cohesionless soil, when talking to the factor of bearing capacity, for example, ataupun from the beginning of the equations, you can see that the first one, pile in for single pile in sand, dia lebih kurang sama, yang mana ultimate bearing capacity is comprises between the Q base plus dengan Q skin shaft capacity ataupun resistance, the QS. But then when it is extended more, you can see that the QB, AB is quite similar again. But later on, you akan nampak the QB is actually consists of effective sigma naught times dengan NQ darab dengan AB. Tadi kalau clay kita nampak as a NC kan? Tapi now untuk sand kita akan nampak dia sebagai NQ. NQ ni is referring to the bearing capacity factor for cohesionless soil. Okay, kalau you tengok kat sini, the cohesionless soil ni, we found one formula that quite similar to the fine soil pile in clay, for example, K tangent delta. K tangent delta ni is similar to the beta, yang mana kalau you analyse pile in clays untuk effective stress analysis ataupun long term stability, kita dah jumpa lah the same formula macam untuk sand. Okay, yang ni lah yang you akan nampak, yang mana the beta ataupun the coefficients will be depending also to the frictions angle of the soil as well as the delta. Itu yang membiasakan beta method dalam sand dan juga beta method in clay. Okay, so far ada soalan tak? Okay, kalau tak ada soalan, I proceed lah. Okay, the explanations on the elaborations of the formula, you akan nampak the effective sigma naught is the effective overburden pressure at the pile 2. So, what we want to estimate bila kita ada QB ni adalah base ataupun bottom of the pile. So, you nak tengok NQ ke apa semua, you kena tengok pile tu, pada bottom pile tu dia berada pada layer sand yang mana, sand layer yang mana. Dia berada pada first layer ataupun second layer ataupun third layer ataupun dia adalah homogeneous sand layer. Kalau dia homogeneous sand layer, dia tak ada masalah. Sebab apa? Sebab kita hanya ada satu nilai NQ ataupun satu nilai or we can calculate the overburden pressure at the last step. Itu yang simple kalau dia melibatkan single layer of the soil. Okay, the Ks is the coefficient of earth pressure dependent largely on the relative density of the soil and the average effective overburden pressure at the center of the pie shaft, and delta is the angle of friction between the pie and the soil. So the NQ may be obtained from the preceding figure in the slide. Okay, yang ni adalah contoh. Kalau you are given the internal friction angle and the ratio between L to B, so that the NQ can be found from here. Kalau kata you ada length pile tu berapa, kemudian diameter dia berapa, kemudian you tahu friction angle of soil tu berapa, so you can have the NQ. Okay, the Ks, delta, and beta, etc. whatsoever is also dependent to the pile material. Kalau kata you ada concrete pile, you ada steel pile, so you have to be careful lah. You kena select the appropriate table. Contoh kalau soalan tu stated that the pile, the steel pile is driven into loose sand. So kita akan tengok the first row dekat steel pile lah. So jangan salah tengok untuk dapatkan nilai Ks, nilai delta dan juga nilai beta. Nilai beta ni pun bergantung kepada nilai phi. Sama ada phi you dalam 25 ataupun 40. If you have a phi in between 25 to 40, yang mana kalau contohnya dia bagi phi sama dengan 30, you kena buat interpolations lah untuk dapatkan nilai dia. Tapi yang tu bergantunglah kalau kata pile tu adalah konkret. Kalau pile tu steel pile, so dia tak ada value kat sini kan untuk phi sama dengan 25 darjah. Okay, similar to previous table, cuma yang ni dia lebih extended lah untuk various type of pile material. Contohnya steel ke, concrete ke ataupun timber. Okay, I hope that there is no problem for you to find delta ataupun Ks. Bergantung kepada informations and look at to the table closely in order to find what is the coefficients for all the parameters given in the formula. Okay, I will not explain all examples. I just take it the important formula because for this week, I'm going to conduct 1 hour, 1 plus few minutes lah untuk kita punya online lecture. The remaining you can access from the U-Future ataupun LA activity and also from any other sources in online on the internet. Okay, look at one example here. In order to analyze the single pile, you are given a diameter of pile is 400 mm and the length is 6 meter to be installed into a deep deposit of clay. So deep deposit of clay pun dia dah bagi you one information. Ada setengah soalan it mention in details by having what? A pile of diameter 400 mm is driven into a deep of clay. Itu pun dia dah mention that driven ataupun bore pile pun dia akan bagi different value of the parameters in calculations. So bila you pergi in advanced courses, you akan nampak how the importance of the installation method might influence into the bearing capacity of the pile, sama ada single pile ataupun pile in group. Okay, back to these questions. So the clay has undrained shear strength of 180 kPa at the depth of 6 meter and average undrained shear strength of 120 kPa over the depth 0 to 6 meter. So kalau you nampak kat sini, you have two value of Cu. Satu Cu at the deep ataupun at the bottom. Yang mana kat sini memang dia dah mention dah. Pada kedalaman 6 meter, nilai Cu adalah 180 kPa. Maknanya bila kita sketch, we can have that at the bottom part ataupun at the 6 meter of the clay deposits, the undrained is 180. Meanwhile, the average depth 0 to 6 meter, the Cu is 120 kPa. So please be careful while you are reading the questions and identify the parameters to be included in your formula. Okay, assuming that NC is a 9 and then alpha is a 0.6, determine the ultimate bearing capacity of the single pile. So, the total ultimate bearing capacity Q sama dengan QB plus dengan QS. So, QB is a bearing capacity at the bottom of the pile, CB and CAB. So, you akan nampaklah sebabkan kita nak calculate pada base pile, so kita akan ambil nilai CU sama dengan 180 lah. Kita tak ambil 120. So kita masukkan 180 darab dengan 9 pi d square over 4. So you akan dapat QB 203.5 kPa. And then for the skin shaft resistance QS, alpha darab dengan average CU darab dengan AS. So AS is the area of the shaft resistance yang mana dia adalah pi BL ataupun pi DL. Pi darab dengan 0.4 diameter of the pile darab dengan embedded length of the pile is 6 meter. So you akan dapat the total the QS is 542.6 kPa. And then we do the summations. So kita akan dapat 746.1 kPa untuk ultimate bearing capacity of the pile. Okay, ini untuk conditions, let's say we have a drain analysis. This is for drain analysis. For the drain analysis, it can say as a long-term effect lah, long-term stability. Kalau you tengok kat sini, this question mentioned that the diameter of the part and then the installations of the method and also the different of the material part yang mana dipakai konkrit, dibuat kat either board to be formed in the soil profile shown in the figure 10.7. To be formed maksudnya kat sini bila kita construct as a bore pile, you kena korek beberapa meter kedalaman tanah, kemudian you pasang reinforcement, baru you tuang konkrit. That's why at this particular time here kat sini, take it by this example, you have multiple layers of soil consists of granular field, kemudian you ada dense gravel and you also have a glacial clay. All our informations are given here for different soil properties for each layer. So you akan nampaklah properties dia tak sama lah antara field, gravel dan juga clay. So it's quite complex lah because it's combined different soil properties for different layers of soil. How are you going to estimate this one? So for this question, you need to estimate the ultimate bearing capacity of the part for different embedded length, for example 8 meter dan juga 11 meter. So how it is shown to you by solution here. Mula-mula, kenapa dia tak terus calculate QS? Kenapa dia tak terus calculate QB? And you boleh lah kalau kata you faham konsep dia, you boleh terus kira QB. Tapi you kena tahulah QB tu berada dekat layer yang mana. Sebab tadi soalan ni dia ada 3 layer kan, 1, 2, 3. Kalau you faham QB tu adalah ultimate bearing capacity at the end of the bottom pile. So maknanya kita akan nampak QB is located in the third layer of the soil pada kedalaman 8 meter. So bila you nak calculate QB, just now I said that QB ni pi can be in sand, pi can be in clay kan. So bila you nak pakai QB sebabkan bottom pile ni berada pada third layer of soil in clay. So kita akan pakai QB dia sebagai C NC darab dengan AB. So kita tak pakailah overburden pressure darab dengan NQ darab dengan AB. Sebab apa? Sebab walaupun bahagian atas ni adalah sand, tapi you kena tengok bottom pile ni dia berada pada clay. So kita dah tak boleh pakai QB yang pi in sand lah. Kita kena pakai pi in clay. That's why kat sini bila you tengok dia punya last solutions clay length 8 meter QB. Maknanya QB ni is located in clay. Dia not calculated in field ataupun gravel. So dia buat CB and CAB. So CB ni pun dia dah bagi kan. Sebabkan bottom ni berada pada 8 meter. So dia akan ambil nilai CU dia adalah 145 kPa. So that's why kat sini dia guna 145 darab dengan 9 darab dengan pi d square. So yang membezakan juga antara layer pertama dengan layer kedua adalah overburden pressure. So untuk layer pertama, layer kedua, so kita dah tak perlu kira dia punya QB. So dia dah solve problem. So QS untuk first layer fill. So kita akan pakai pi darab. This is the shaft lah, shaft area of the pipe for the first layer, pi dl. Ataupun dalam this particular sebabkan dia punya length dia untuk first layer ni adalah 3 meter. So kita akan ambil 3 meter. Kita tak ambil lah sebagai 8 meter sebab different properties of the soil untuk setiap layer 1, layer 2 dan juga layer 3. That's why kat sini pi darab dengan 0.5 darab dengan 3 darab dengan 1. 1 ni adalah KS darab dengan overburden pressure. Overburden pressure kat sini dia punya simbol dia. Sigma sama dengan gamma darab dengan Z. Okay, dalam this case, overburden pressure kita akan ambil at the center of the depth. So, atau erti kata lain dia adalah average overburden pressure. Average effective overburden pressure. That's why when you look at to here, 20 ni adalah unit weight of the soil. Darab dengan 3 ni adalah depth of the layer bahagi dengan 2. Kenapa bahagi dengan 2? Sebab kita nak dapatkan average ataupun overburden pressure tu kita hanya ambil the mid of the center layer. Darab dengan tangent 0.75 darab dengan 30. So we solve one layer. For the second layer, untuk kita dapatkan dia punya effective overburden pressure, so now the soil in the middle, maknanya gravel ni dekat bahagian layer nombor 2. So dia akan carry overburden pressure from top. That's why mana datang 60? 60 adalah unit weight 20 darab dengan 3 campur dengan unit weight for the dense gravel is 21. Dia punya Z is 4. 7 tolak 3, 4. Lepas tu bahagi dengan 2. So kita akan dapatlah the overburden pressure at the center of the layer in the dense gravel. So darab dengan tangent 0.75. Untuk clay, okay, clay ni sebabkan pada 8 kedalaman ni, pada kedalaman 8 meter ni, dia ada dua nilai yang memberi kepada CU berbeza. So, at this time, you kena dapatkan average CU. The average CU at the 7 meter dan juga average CU at 8 meter. So, the average CU at the 7 meter is 120 kPa and at 8 meter is 145. So, you bagi dengan 2. AS masih lagi sama iaitu pi dl ataupun dalam this case L dia adalah 1, 8 tolak 7. Kemudian dia punya diameter pi masih lagi sama 0.5. So you akan dapat the answer here. And then saya just show answer for 8 meter lah. So kita jumlahkan antara QB dan juga QS. So you akan nampak lah kenapa QS ni ada 3. First one from the field, and then from the gravel, and the last one from the clay. So you total up, you akan dapat the QU at 8 meter depth is 1071.8 kilonewton. Okay, ini go back to your own study lah. Ini just show you how to get the ultimate bedding capacity ataupun the Q allowable having the FOS. Okay, negative skin frictions. So the negative skin friction, as I said, bila kita penetrate pile, kita akan dapat satu forces antara the resistance force between pile and the soil additions in the upward directions. Tapi bila kata negative frictions, you akan nampak it is having moving downward directions and results in the increase of the load on the pile. So maknanya dia akan bagi arah yang sama dengan arah penetration pile. So they supposedly not that way lah. Apa yang berlaku bila kita ada negative skin frictions adalah piles are driven through a layer of fill material which slowly compacts or consolidates due to its own weight. So the layers underlying the fill consolidates under the weight of the fill. So this is how it says lah. Yang mana the negative frictions presence in this filing process. So sepatutnya dia tak berlaku begitu, and you can see that it happened in the field dan juga clay soil. So there will be created additional load along the shaft. Itu yang tak bagusnya berkaitan dengan negative skin fractions. The general equations ataupun the general expressions for the load carrying capacity of the part subject to negative skin friction as a given here, yang mana Q plus dengan summation Qn ASN. So Q is a QBAB plus dengan QS ASR. Dia masih lagi sama, iaitu dia consists of the Qn bearing campur dengan Q skin frictions. Okay, now we go to the pilot in group. Pile group design. Okay, dalam pile group design ni, the simplest way is that, for example, contohnya, kalau you calculate ultimate bearing capacity, for example, just now is 1071 kPa. Kemudian you dapati load carrying capacity ataupun load design yang daripada superstructure tiang, kemudian rasuk daripada lantai tu adalah lebih besar daripada ultimate bearing capacity. At this particular time, kita dah tak boleh pakai single pile. And then the pile must be constructed or must be designed in a group. So kalau kita ambil the simplest idea is that satu pile dia akan bawa ultimate bearing capacity sebagai 1000 lah contohnya. So kalau kata kita ada 4 pile, so kita akan dapatlah the ultimate of the pile load group is 4000. That's the idea. And then how do you get the efficiency of the pile group? So the efficiency of the pile group can be estimated from ultimate group load bahagi dengan number of pile darab dengan ultimate individual load. So that tell you the efficiency sama ada dia sesuai tak untuk carry the loading in the pile capacity ataupun in the pile group. So the efficiency of the pile bergantung kepada jenis tanah dan juga jenis installation method. Kalau kata in sand, the efficiency it can be take around 1 to 1 lah. Maknanya kalau efficiency dia 1 pun boleh, ada sometimes efficiency dia lebih daripada 1. Tapi kalau dia bergantung pada bore pile, installation method dia menggunakan kaedah bore, so the efficiency is 0.6 due to overlap shear zones. So in a pile group, in order to integrate the piles in a group, kita akan wujudkan satu platform in between that we call it as a pile cap. Pile cap itulah yang memegang kesemua pile-pile yang kita susun dalam kumpulan. Sebab kalau you look at tadi single pile tak perlukan pile cap. Dia boleh stand alone ataupun it can be penetrated into the ground alone by itself. So dia tak perlukan pile cap. Tapi kalau kata you have calculated you need to have more than 4 piles. So how to construct 4 piles in one location in a group? So we provided a pile cap. Pile cap tu nanti dia ada some concept or idea how the arrangement of pile can be constructed in a pile group. Contohnya kat sini dia bagi some idea kalau kata pile you in the freestanding ataupun pile you dalam keadaan fully embedded or somehow others yang berada dekat permukaan. Dan dia bagi juga some idea kalau kata you have 4 piles, so the arrangement of pile can be this way. Kalau kata you ada odd numbers of pile, number ganjil pile tu macam mana kita nak susun? Takkan kita nak susun pile keliling bulatan pile cap tu kan? So the idea is that they produce, we have 4 sets of pile around the perimeter. Kemudian kita akan letak pile berada di tengah-tengah. Similarly, kalau you ada pile 3, you ada 3 pile. 1, 2, 3. So kita nak buat pile cap bentuk apa? 4 segi ke? Ataupun kita nak buat pile cap dalam bentuk yang berbeza. Contohnya hari tu kita tengok the speaker shows you the pile cap for 3 piles arrangement. So they will be different. So bergantung kepada bilangan pile yang you ada. Kalau kata pile group in cohesive soil, so the ultimate bearing capacity of the pile group can be estimated from these equations. Okay, the next one, when we talk about pile, sama ada in single ataupun in a group, dia akan create a settlement. Sebab bila kita penetrate into the ground, even in the dense sense ataupun in the soft clay, so you may see the changes in the depth. Dia berlaku pergerakan tanah. Pergerakan tanah tu mengalami enapan. So the enapan or the settlement can be estimated from these equations, primary consolidation settlement, ataupun from this one equation by having or by determining the increment of the vertical stress due to the pilot in group. So dia contohnya dalam this case, kalau you nak dapatkan the changes in effective vertical stress, delta sigma V, so kita kena calculate dulu berapa ultimate pile group, kemudian what is the BG plus dengan Z plus dengan times dengan LG plus dengan Z. So in this figure also shows you that bila kita ada pile group, the stresses ataupun the settlement can be estimated by this way dengan stress distribution in ratio 2:1 dengan dia punya L/3 and somehow 2/3. These cases bergantung kepada load transferring lah. And then also the Z. So Z, BG, LG ni is depending to the pile group ni dimensions. So we want to estimate the piles, the settlement of the pile group by looking to this one and these figures to estimate what is the delta sigma Z, barulah kita boleh masukkan dalam formula untuk kira settlement. Okay, the piles are usually placed in the groups with center to center spacing, typically between 2 and 5 diameters. So the ratio of the average load in pile group to the ultimate single pile load is referred as the efficiency of the group. So ini yang saya explain tadi. This is the idea, the arrangement of the pile groups. Okay, how about piles in cohesionless soil? So piles in cohesionless soil, it depends to the design purpose. Ada yang considered as a one efficiency ataupun ada yang ambil lebih daripada satu. So piles driven into soil, dia bergantung kepada relative density. Ada relative density increase dengan group bearing capacity. So that's why the efficiency number will be different. And then for piles constructed as a ball pile in sand, so the efficiency will be lesser compared to driven pile, iaitu 0.6. Okay, the ultimate bearing capacity for the pile group can be estimated from this equation, NC CU BG LG plus dengan average undrained cohesion 2D times BG LG. Okay, ini yang dia define balik lah apa dia BGLG. So BGLG ni kalau kita tengok, this is one example. You have a pile group. Kemudian D is the embedment depth of the pile. And then this is original L, overall length ataupun overall width. And then the LG is counted from the spacing of the spacing of the pile campur dengan the size of the pile diameter. So nampak BG ni dia akan extend sikit lah daripada the side of the diameter. Okay, one example here, conditions where you have a pile group of 4 friction piles in cohesive soil. The diameter of each pile is 0.6 and center to center spacing is 2.5 meter and NC sama dengan 7. So the diameter each pile is 0.5 meter. So maknanya dia punya radius tu adalah 0.25. So apa pentingnya informasi tu untuk kita kira dia punya LG. Contohnya tengok kat sini, kalau kata kita ada spacing pile is 2.5 and then how it get the LG sama dengan ataupun BG sama dengan 3, iaitu 2.5 campur dengan 0.25 dekat bahagian tepi ni campur dengan 0.25 dekat bahagian this sides. So you akan dapatlah 2.5 campur dengan 0.25 campur dengan 0.25, you akan dapat LG dengan BG sama dengan 3. Ini sebabkan the pile group arrangement in square. So kalau kata pile group arrangement in different shape octagonal ke apa, so dia berbeza lah kan. So you kena kira lain lah. Okay, dia bagi maklumat lain. Depth is a 20 meter, undrained clay is a 80, diameter is 0.5. So for the first one, we can estimate the ultimate bearing capacity by having the addition factor 0.6. So the answer is 1,100 kilonewton for single pile. Kemudian for ultimate bearing capacity of the group pile, so this is what supposedly to be. Sebab kita nak pakai this formula. Formula ni yang sesuai untuk group pile. Yang formula tadi ni untuk single pile. Okay, this one for single pile. And then for group pile, kita dah dapat dia punya equation. So kita insert balik. So the group pile consists of 4 friction piles equal 14,640 kilonewton. Okay, how to determine the efficiency group? The efficiency group is the ultimate bearing capacity of the pile group bahagi dengan number of pile darab dengan single ultimate bearing capacity. So the efficiency is 3.33. So that is the maximum. And the next question asks you calculate the Q equivalent. The Q equivalent ni is the situations where you want to estimate the settlement by block failure of the pile group. Okay, first of all, you kena dapatkan initial Q dulu. Initial Q sama dengan group ultimate bearing capacity bahagi dengan area of the pile group. So kita dapat 1626.67, and then we want to estimate the effective depth of these stress distributions is a 2/3 over D. So kita akan dapat dia punya kedalaman tu adalah 13.33 meter. Kemudian we need to determine the L1 dan juga B1. So the L1 is the LG plus dengan 13.33. 13.33 ni yang kita dapat daripada 2/3 tadi tu lah, 2/3. Kalau you tengok stress distributions ataupun settlement by block of the pile, first one kita akan dapat 1/3 kan, kemudian kita akan dapat 2/3. So it's like a stress distribution in triangle shape lah. Kemudian you have to calculate the area equivalent. Area equivalent is L1 times dengan B1. So kita dapat the area is 266 meter square. So the Q1 or Q equivalent is equal to 54.9 kilonewton per meter square. So ini adalah load effective. This is the stresses below the pile group. This is the point that referring to the stresses due to the pile load in group. Okay, settlement ni lebih kurang seperti yang saya bagi contoh tadi, tapi yang ni dia lebih specific explanations lah, yang mana it says that the area of the equivalent rough is determined by assuming that the load spreads from the underside of the pile cap in the ratio of 1 horizontal to 2 vertical or whatever is given. So the settlement is then calculated by conventional means. So this is how it says that bila kita dapat these kinds of the problem yang mana kita assume sebagai pile load in group as a rough, and then we have the stress distribution. So we want to estimate the settlement of the pile group. It can be adopted the technique. Teknik tu kita boleh gunalah semula untuk dapatkan dia punya value of the settlement. The value of the settlement by its concern to determine the effective increase, the increment of the effective overburden pressure delta sigma z. So the delta sigma z is equal to the ultimate bearing capacity of the pile group bahagi dengan VG plus Z times dengan LG plus Z. So in this one, it says that sometimes a pile group may be embedded above a soft clay layer and transfer sufficient load to it, soft clay, to cause consolidation settlement. To estimate the settlement, the full design load is assumed to act at a depth of 2/3 L, where L is the embedment depth of the pile. The load is then distributed in the ratio of 2 to 1 vertical to the horizontal. So the increment of the vertical stress at the depth Z is given by here. Kenapa benda ni penting Sebab benda ni dia tak sama macam formula untuk kita kira the stress increment due to the shallow foundations. Kalau you tengok balik dulu masa you nak calculate the vertical stress ataupun the stress increment due to the strip loading. So strip loading is on the shallow foundation yang mana dia hanya melibatkan one single structure. Untuk kira stress increment for different structures lain daripada strip footing ke, on this particular for the pile group it assumed as a rough foundations. So bila kata rough foundation is a large structure lah, so that bila nak kira dia punya stresses increase tu, dia nak simply as a Q darab dengan influence factor. So kita kena consider the ultimate load bearing capacity of the pile group dengan dia punya B group dan juga L group. So once you have that delta sigma Z tu, you boleh masukkan dalam settlement equations lah, iaitu S sama dengan MV darab delta sigma darab dengan H. MV is the coefficient of volume compressibility. Okay, selain daripada guna SC MV sama dengan MV darab delta H darab H, kita juga boleh guna kaedah yang lain lah, yang mana kita panggil sebagai primary consolidation settlement. You have the initial thickness of the clay plus dengan initial void ratio, and then you ada compression index, you ada initial overburden pressure, and then you ada pre-consolidation pressure. Kalau you ada this kind of the information, so kita kena pakai equation number 2 lah. Kita dah tak boleh guna equation number 1. Okay, contoh seterusnya, bagi you too many, it's not too many lah. I mean that it's covered by having how to determine the effective equivalent Q, kemudian how to estimate the settlement before and after loading by substitute into this equation primary consolidation settlement. So you can see further in order to understand how the effect of the pile group in the settlement from point of view through the calculations of primary consolidations. So you can see that the stresses increase before and after loading at the point A. So then at this particular time to calculate the sigma C in this equation, so kita kena masukkan sekali the effect of the equivalent loads. Okay, do you have any questions? So yang ni pun ada some give you notes lah how to determine the spacing between piles in group, and then the arrangement of the pile if you have a even number of piles ataupun odd number of piles. Okay, ada soalan tak?
So far no.
So far tak ada.
Okay, untuk pile ni kan, tak silap saya, masa kita just touch in the topic 2, ada satu LA activity yang saya minta you watch the video. The first activity LA in topic 2 ni dia cover video from shallow foundation dan juga deep foundations. So you can go there, watch again for the video number 3 dengan video number 4 for detailed explanations, ataupun just go to the what we have recorded in the last Friday talk. Tapi yang tu quite simple lah, but in terms of the manufacturing informations, so dia bagus lah sebab dia bagi pada awak pendedahan. Kalau you tengok the last Friday talk ni, it also covered from the structure punya section dan juga from geotechnical punya section. And if you look at throughout my class just now, saya hanya concentrate on the geotechnical structure, yang mana kalau betul lah kan kita nak design a pile ni dia bergantung kepada dia punya concrete strength lah. If we talking about a pile is made from concrete, dia bergantung kepada concrete strength. FCU dia pada 28 days berapa strength dia, FCU pada 14 days, and then macam mana yang kita panggil sebagai pre-stressed concrete pile kan. So, and then what the beneficial between concrete dengan steel pile. So yang tu saya tak cover sebab itu adalah structure. Kalau kita tengok details pun kan sebenarnya bila kita talking about the pile ni, it's not only we concentrate the pile strength tau. Kita kena tahu juga the reinforcement size, reinforcement arrangement. What we focusing here is on the geotechnical aspect, yang mana macam mana the impact of the pile into the soil. So we concentrate only the geotechnical aspect in calculations the ultimate bearing capacity of the pile dengan soil interactions. So daripada situ you akan nampak some parameters from the soil properties, contohnya phi, kemudian nilai C, the delta is the relations between the soil frictions angle dengan pile itself. So itu je yang kita concentrate. Tapi kalau you go further in the master level ataupun in advanced courses, you can see that we are not only focusing on geotechnical aspect, we also need to consider from the structural aspect. That's why last Friday talk it was good lah, because the speaker also involved the point of view from structure itself. Macam mana manufacturing kita nak control quality supaya kita boleh dapat the good strength of the concrete what we want. Similarly, kalau kita ada H steel bar, hollow steel bar, kemudian steel pile, ni semua boleh pakai dalam geotechnical. Macam sheet pile. Sheet pile ni dia tak pakai daripada konkrit, dia kena pakai daripada steel. Kenapa kita pakai steel? Kenapa kita tak pakai konkrit? Itu yang kita tak cover lah. Sebab kalau you tengok konkrit ni is quite sensitive kepada saline content, kandungan garam. So kalau kita nak pakai konkrit dekat kawasan ocean yang high salinity tu, so kita kena pilih the right concrete strength lah. So this is out of scope for this topic, so I will not cover in detail. So I hope that you can have your own further study on part of this one. Because what I say here is that bila you belajar one of this one topic in the civil engineering branch, you kena orang kata apa, think beyond ataupun outside of the box. You cannot think just in the range of the scope. Kalau kata for the purpose of the study, yes. Tapi bila kata when you are having a group discussion, you can extend more. That is the difference between student A dan juga student B. The ability to think beyond of the scope of the content. Because of what? Bila you pergi interview ataupun let's say you have a questions final exam yang not in directly from a book. So you have to think macam mana kita nak bagi a concrete answer that is relevant to be accepted by the examiner. Itulah yang kita nak terapkan. Maknanya kata you have interest in civil engineering, tak semestinya in one particular branch geotechnical. You can actually go all branches dalam civil engineering, contohnya structure, water. There's some connections. Maknanya bila kita study geotech, dia ada connection dengan structure, dia ada connection dengan water. Itulah maksud saya. So bila belajar tu, jangan concentrate in one thing. You can extend more. Okay, I think that I have finished today. So the next week will be on topic 3 before you have a special leave for Gawai. So this will be my last lecture with you. So after this will be taken by other lecturer. So saya nak ambil kesempatan ni lah untuk say thank you dan juga harap maaf lah kalau ada kurang dari segi lecture ke apa kan. So whatever relates to this topic for your final exam preparations, you can contact me through the MT chat or any other platform. Okay, Assalamualaikum and goodbye.
Waalaikumsalam.
Thank you, Doctor.
Waalaikumsalam, Doctor. Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.